Right. So the theorem we had stopped at in last class was which one, boy? Let me see. Right. So we had looked at angles standing on the same arc or chord are the same. We had looked at the angle between the radius and a chord is 90 degrees. We looked at the angle in the center would be 2 times the angle at the circumference. Okay. So let's continue. So let's look at the ones. Let's focus on the ones we didn't do as yet. Right? So that's Ron. Let me know if you're there. That's Ron?
Yeah.
Yeah,
I
just
hear.
quick recap, right? Last class, we said that, if you have angles standing on the same arc or chord and they was in the same segment, they would be equal. Looked at that one. We also said that
Yeah.
if you have a chord here, then the line drawn from the center to the chord would form a right angle. We also looked at this one over here. So essentially, if you have two angles standing on the same arc or chord, then the angle at the center would be 2 times the angle at the circumference. And we was to move on to this one, right? So let me go over this one in detail, right? And this one has come plenty times. All right. All right, so Desron, you will let me know if you remember this, right? First things first, Desron, and everybody in class. Do you all remember what a
Yeah.
tangent is? Does everybody remember what a
Yeah.
tangent is? Yeah? So, quick question.
Yes, sir.
Do you all think that that would be a tangent? That's a tangent?
No.
No, sir.
Why is that not a tangent?
Because it's inside the circle.
Yeah, other than that, it passing through 2 points. You would call that a what? Starts with S. S. S-E.
Segment.
Well, that's
Secant.
A secant. Secant,
Oh.
yes. Right? A segment, if you're talking about a segment is actually a portion of the circle that you get when you have a chord. So Ria, if I draw a chord, if I put a chord in the circle, and I would now have different portions.
Oh yeah.
That would be a
Yeah.
segment, right? So a tangent is a line that is grazed the circle. In other words, it touches the circle at one point along its circumference. So this theorem says that if you have a triangle, so we have a triangle here, right? Then the angle between the tangent and the triangle would be equal to the interior opposite angle. So if this is theta, then this angle here would be theta. Now, guys, tell me, when you hear words like interior opposite angle, I know that the song kind of complicated. Sky, and this song a little complicated. Interior opposite angle.
A little bit.
All right, let me break it down. So you understand that this will be the angle between the tangent and the triangle. Yeah? Come if you understand that.
Yes, sir.
Right. Give me a value for this. Give me a value fast. Any angle. What angle are you
This is
looking at?
like 60.
60? Uh,
I just guess.
you guys like 68. All right. So this theorem says that the angle between the tangent and the triangle is equal to the interior opposite angle. What does interior sound like? Interior.
On the inside.
Inside. So
Of
we're talking
the-
about inside the triangle. Now, interior opposite. So we're talking about the angle that's inside opposite the 68. So that would be this angle. Right? You understand that?
Right. Yes, sir.
And the way I tell my students to remember it is just draw an arrow. Right? So that is one case over there. All right. Do we have wait, I'm hearing somebody. Oh yeah, Carissa, you asking a question?
No. I wasn't asking a question.
All right, but since you're unmuted, let me look at the other angle, right? So Carissa, this is a tangent and this is a triangle. You okay with those things?
Yeah.
All right. And to have an angle here. And you can see the angle there that's in between the triangle and the tangent. Tell me if you're seeing that.
Yeah.
So we have a tangent over here, right? And we have a triangle. And as such, we'd have an angle in the middle. So we'd have this angle over here. Now, let me just give it any value. We could probably call that like 50 degrees. So, Carissa, if I'm saying that that angle would be equal to the interior opposite angle, what does interior sound like? Interior does sound like what?
Inside.
Right.
So
So an
okay.
opposite, it'll be this. It'll be
The
equal to that.
longer here. The longer side.
Right. I'm gonna just draw my arrows. So, Devon, way, boy, way. Devon, that was you.
Where's my? Yeah,
Way.
boy.
That's crazy, bro. That's crazy. You see Big Bad Wolf?
While I was studying, I unmute shucks.
You
I
should
too
probably mute
focused.
yourself. All right.
Yeah, boy.
Yeah. Yeah. Let me continue, right? So I'm just going to write down the theorem for this. So this theorem says the angle between the tangent and side of the triangle is equal to the interior opposite angle. Cool. Is there anybody that is confused by this? Tell me no. Tell me, guys. Is anybody confused? Talk now or forever hold the peace. Mira, are you confused?
No, it's pretty straightforward.
Okay, good. Glad to hear that. It's fine. So I'm gonna move on, right? I'm gonna move on. So you need to know this theorem. This come a lot. This come very, very frequently. Right. This one extremely easy, right? This is one of the most easiest ones. Does everybody in class know what a semicircle is?
Yes, sir.
Okay, good. I just making sure. So a semicircle is just half a circle, right? And so this other theorem says that a triangle formed in a semicircle will always be a right angle triangle. Let me explain what I mean by that. So, Sky, if I were to draw a line from this point of the circumference and it passes through the center and it goes to the other end of the circumference, what would I call that? That's how what?
Diameter
The diameter does do what with the circle? Like if you look at it, it cuts any circle
into two pieces.
into what pieces? That's with E,
Even pieces.
right? Equal or even pieces. And so wouldn't I have two semicircles now?
Yes, sir.
Right? And the theorem says that if I make a triangle in a semicircle, then the angle at the circumference would be 90 degrees. So watch. If I do that, the 90 degrees would be right over here. See that? Tell me if you understand that.
Yes, sir. See it.
Okay, let me do another one. What if are you seeing the 90?
Yes, sir. Upper left corner.
Right. So this theorem says that, let me write down the theorem. So you will notice that there are, so essentially, based on who's writing it, the theorem might be a bit different, but it would encompass the same information. So this theorem says that an angle formed, wait, a formed in a semicircle always be right. Right. So anytime you form a triangle in a semicircle, the angle at the circumference is always 90. So it always forms a right angle triangle. Now we could write that, we could write this, and I know everybody gonna write this instead because it's simpler. Angle in a semicircle is 90. Simplest way to write it. Right. So is there anybody that's confused about that theorem? Tell me now. Okay, I'm not hearing anybody, so I'm gonna move on. Before I do, if I had this diagram here, can we assume that this is 90 degrees? Let me hear. Somebody tell me. Can we assume that that's 90 degrees there? Could we assume that?
Yeah.
Nah. Mm-mm. Can't do that.
Oh,
They're not going to the diameter,
oh
not
yeah.
through the middle.
Yeah. Yeah. And this rule is only work if it's a triangle being formed in a semicircle.
Yeah, I didn't see that it wasn't equal.
And besides let me ask you this, let me ask you this, right? Are you even seeing a dot in this? Are you seeing the center? Tell me, are you seeing the center?
No.
Nah. So you can assume that this is the diameter. You can assume that. The only time you could assume that is when the line directly passes through the center. So the theorem would not work for this question, right? Just some things to keep in mind. It needs to be a diameter, right? Okay. 6. Tangents from a common point to a circle are always equal in length. Priscilla, when you did the homework, and you would have see this?
Yes, sir.
Right. Right, so let me just go through this theorem real quick. So if I have a circle over here, and I have this point over here, what do I want to call the point? Somebody give me a letter.
E,
E?
E,
I can't tell if it's saying A, B, or E.
E.
A, okay. So let's just say we have a point there, right? If you draw two tangents, all stemming from that same point, then when they cut the circle, right? So Ollie go tell me if I'm losing Ollie, right? As soon as Ollie start to feel lost, tell me. So far I said that if I have a point and the two tangents coming from this point where they touch the circle, if I were to connect it, this would be equal to this. That's what I'm saying. Let me run that back one more time. So if I have tangents coming from a common point outside the circle, then wherever it is touching the circle, if I were to connect those 2 points, you would see that this length and this length are equal. So in other words, guys, it forms a what kind of triangle? If I were to put B here and C here, I would say that triangle ABC is what? Is a what kind of triangle?
Isosceles.
The isosceles, right? And this also comes. This also comes. So that's why I actually made you all do some revision on triangles before we start with this, right? So let me just write that down, right? Tangents tangents from a common point outside right? So tangents from a common point outside the circle from let me get the exact wording, right? Right. Right, tangents from a common point outside the circle are always equal in length. Right, are always equal. All right, so Desron. Desron, if that is the case, I would say that AB is equal to what? Or would AB be equal to? So Desron, if you're looking at the diagram, AB would be equal to what? Okay, I'm not hearing Desron. Anybody? Okay, I see you on mute. Yeah, Desron, talk.
Um, um, AB equal to AC,
Correct. And Desron, since these sides are equal, it forms a what kind of triangle?
and our isosceles triangle.
And if that's the case, you could imagine if they gave you this angle in the exam, and let me just say they give you this as 70 degrees. Is it possible for you to find this angle and this angle?
Yeah.
How would you find these two angles?
Um, you have to you have to minus um you have to minus the 170.70 from 180 and divide by 2.
Correct. Correct.
That's
Yeah, that's correct. Carissa, do you remember that if you add up all the angles in a triangle, it would be 180?
Yeah.
All right. And do you understand that for isosceles triangle, the base angles are the same? So this angle and this angle will be the same. Some of you understand that.
Yeah.
So if they give us this angle as 70, then any remaining angles would be 180 minus 70, which would be 110. Am I not confusing?
It's not confusing.
I'm gonna run that back one more time. If they give you this as 70, right?
Mm-hmm.
And you wanted to find the other angles. Now keep in mind, and these two angles here are equal,
Yeah.
all right? And so if I wanted to figure out what the sum of the remaining angles would be, I could take away 70 from 180, and
Yeah.
we have 110. So,
Right.
Carissa, in other words, these two angles here, the remaining angles, have to add up to what?
110.
Right? And they're the same. So I could just divide that by 2 and I get 55. So 55
Yeah.
degrees is what each of the base angles are. So this
Yeah.
also comes in the exam. So just be aware of this. Right?
Yeah.
All right. Okay. Um, I want to hear who could pronounce this word. For some reason, plenty people just have a hard time pronouncing this word. So somebody pronounce this. Let me hear somebody pronounce it. Any volunteers? Adetola, you there?
Yes, sir.
Okay, I want you to pronounce this word for me.
Cyclic.
Ah, nah, cyclic. Yeah,
Um,
it's a weird word. It's a weird word.
hmm.
Yeah. Right? Cyclic. So, Adetola, since you're unmuted, I want you to read the theorem one time and I'll run through it and we'll do an example together. So, read the theorem for me.
ABCD is a cyclic quadrilateral. All vertices lie on the circumference of the circle. Opposite angles add up to 180 degrees. A plus C is 180 degrees and B plus D is equal to 180 degrees.
All right. First things first. You're seeing quadrilateral. When you hear quad, what do you think about? Quad.
A four-sided shape.
A four-sided shape, right? So it must have four sides. And what makes it cyclic? It's cyclic if the quadrilateral touches all the vertices, if all the vertices touch a point on the circumference. right? So add it together. You see how this point on the circumference, this point on the circumference, this point on the circumference, and this point is on the circumference. You see now?
Yeah.
That's what makes it cyclic, right? And if that is the case, let me show you what we could do, right? So 7, all right. Tell me, guys, is that a cyclic quadrilateral? Wait, is this a cyclic quadrilateral?
No.
I want somebody to tell me why is
No,
it
sir.
cyclic quadrilateral?
So points on the bottom not touching.
Exactly, not touching. Right? For this to be a cyclic quadrilateral, all of its vertices need to lie on the circumference. Right? So let's just put a definition for what a cyclic quadrilateral is. Right? It's a four-sided shape whose vertices lie on the circumference. A four-sided shape whose vertices lie, lie on the circumference. All four need to be on the circumference. No exceptions. All four. Right, so fear not, guys. Today, we're going to start past paper questions. So I know you all very excited. Sky, aren't we very excited? We ecstatic.
Yes, sir.
You gotta say it with a little more enthusiasm. You're sounding like you're gonna knock out the. You gotta say with excitement, boy. Sky, you had a long day today?
So kind of it's cool.
Say that again.
So yeah, kind of. But
I know.
school was kind of long. Yeah.
So we understand what a cyclic quadrilateral is now. So let's actually look at the theorem. So it says that the opposite sides, the opposite angles have to add up to 180. So let me just call this A, B, C, and D. So in other words, if I say that this angle A, what angle A looking like? Somebody tell me. Let me hear some suggestions. What are looking like? Angle A. Guys, give me a random angle. What are looking like?
So 110.
110? Mm, it looking like a little less than 90. I could probably put 89. Okay, and the theorem says that opposite angles have to add up to 180. So could somebody tell me what the opposite angle to A is? What's the opposite angle to A?
See,
See, Mira, I find you real quiet today. Is everything okay? Is everything all right? I guess not. Well, I hope everything okay. So could somebody tell me what angle C would be? If we know that it has to add up to 180.
you want the full equation or you just answer?
Give me the whole equation,
180 minus 89,
right? And that should be
91.
91, right? Mhm. Okay. And if I give you this side to be 101 degrees, what would this side be?
180. minus 101 is 79.
Correct.
BD equals. You have to write out the whole equation. Like you have to put AC is equal to 180 minus. You'll have to write it out, I know.
For this case, where it's just an explanation, no. But when you're doing the
No, but
question,
I mean, like, yeah, for the question.
yeah, I would recommend that you do it in the question.
Okay.
Right, so 180 minus 101, that would be equal to 79 degrees. Mhm. So is everybody okay with this particular theorem? Let me know if you're okay with this theorem. Ria, you okay?
Yeah.
Yeah.
Yes, sir.
Okay. Okay, nice. Nice. Glad to hear that, Joshua. All right. And well, the last one, we know this. The angle between our radius and our tangent is 90. Yeah, we know this. Right, well, I'll just go through it nonetheless. So if you have a circle, then the angle between a radius and a tangent will be 90 degrees. Right? The angle right, let me just write on the theorem here, right? For a cyclic does anybody know a fancy word for adding up to 180 degrees? That's with S. If angles add up to 180 degrees.
Straight line.
Say that again?
Straight line.
Nah. It kind of sounds like supplement, but it has supplement in it. All right, so if angles add up to 180 degrees, then you would say that the angles are supplementary, right? Right. So you could say opposite angles are supplementary. Mhm. So before I do the questions, is there any theorem you'd like me to go over? Let me know, guys. Sky, Carissa, Ria, Joshua, Adetola, Desron, Presea, Stefan, well, not Stefan, Mira, Jada. Guys, is there any theorem you'd like me to go over? Let me go back to the table with all. Let me know,
No,
guys.
sir.
Carissa, you good?
Yeah.
All right,
Pretty
Sky,
straightforward.
nice.
Sir, I got enough.
You good? Okay.
Are you calling me out, boy?
Stefan, you're not doing this. But I read it. I read in UE.
Yeah, we doing that. I understand, but you calling me out, boy?
No, I forget he's not part of the class.
You like.
Stefan is like the co-host, guys. Stefan is like the co-host. Yeah.
We like.
Right. Stefan, we gotta run our TikTok live. Wait, yeah. I will let you know what day, right? And we do our TikTok live. I feel like we should
But
do it
upon,
right in UE, you know. Could do a TikTok live right in UE.
but upon what? Do like just random theorems, doing maths and
Say that again?
like upon what? Just random maths.
Yeah. Yeah, we could do I could do circle theorem, I could do functions. No. Yeah, circle theorem is real give people trouble. That's on vectors. Could do that.
So the theorems I could understand because I last book I have to pack in your head before you could apply it to the questions. I understand why that would be my trouble.
But what about vectors? Let me find out from everybody. How are you guys with vectors? How are you all with vectors? Let me hear. A lot of you all here are rewriting the exam. Is vector something that give you all trouble? Those rewriting the exam, is vectors something that is troublesome?
So I would have to agree with that. Vectors, matrices, and I think it have an I forget I think it's now with a B.
Barons?
Okay.
Barons.
Yeah.
Yeah. All right. So let me jump straight into the question. Right. So Desron, you're gonna help me out here. So Desron, you're gonna help me out with this one, and Sky, you're gonna help me out with the other one. Right? So Desron, give this question a read for me. Desron? Desron moving real quiet, boy. I hear Desron. Um Perseus, you help me then. Right? I promise I'm not picking on your case. I promise. I promise. Right? So
So I just hoping I just prayed for is you forget me with one
no.
question.
I don't forget my students. I don't forget my students.
No, I just hope when you forget me with one question because I don't want you to ask a question at all. Um,
That's the thing, eh? In math vibes, everybody is talk. Everybody's talk. Yeah. Everybody's be talking. So no matter how much you try to be in the background, at some point you will talk. So give this question a read for me. And let me run through it together.
with on top or below, calculate giving reasons for answer the measure of one.
Read the top part from the two.
Okay, the diagram below, not drawn to scale, shows a circle, center O, EH and EF are tangents to the circle. FOG and JOH are straight lines. The measure of angle FEH equals 44 degrees.
Nice.
Calculate
Yeah.
given
Right.
reasons for your answer, the measure of.
All right, and we have the angles here. So before we even begin, let me see which theorems we can see at the start. So not just Priscilla's, I want everybody to volunteer. Are you guys seeing any theorems that we could potentially use? I'm gonna start you all off. I am seeing angle in a semicircle is 90. I see in that one here. I see in that over here, right? And I'm also seeing it over here,
From a common point.
right? You have tangents from a common point. So,
Right.
Carissa, that would make this triangle a what?
Isosceles.
Nice. And you can find for this, and you can find for this. Cool.
Yeah.
Are you all seeing any other theorems?
Um,
So,
cyclic quadrilateral.
Yeah. Cyclic quadrilateral. Mm-hmm.
so I was gonna say angles are not the same photo arc.
Yes. Big up you for seeing that. You talking about this?
Yes.
So it have it over there, and it also has it over here. Some of you seeing that? Thomas guy, seeing that?
Yes, both of them.
Okay, nice. Now there are two more other theorems that I could see. Two more theorems I could still see. See if y'all could come up. See if y'all could figure out the other ones. So, so far we talk about tangents from a common point. We talk about this. We talk about cyclic. We spoke about semicircle. You know, the angle in a semicircle is 90 degrees. We talked about angles standing on the same arc or chord at the circumference are equal. Same. Right? Are you all seeing any other theorems? Actually, I see in three. I see in three. Three more.
The one with the radius and the tangent that is 90 degrees.
Right?
That's one?
Yeah, so radius right here, tangent right here. Right? Radius and tangent.
Excuse.
Yeah, Thomas Guy.
I can step away for a bit.
Sure. Right? I'm still seeing two more. I'm still seeing two more theorems that could be used. Perseus, you actually utilized one of the two are trying to get you all to say. Anybody seeing any other theorems? Should I nudge you all in the right direction?
Yeah, not just in the right direction.
So what about the quadrilateral?
Say that again?
The the theorem with the quadrilateral.
Oh no, I mentioned that already. Cyclic. So check this out, right, guys? So you have a tangent from the same point. So essentially, this triangle will be isosceles. And if that's the case, you'll be able to find for this and find for this. Now, check this out. Are you all seeing what I'm seeing? We have a tangent over here, and we have a what? So the angle is in between a tangent and a what? And a what? So where's
The
that?
side of the triangle.
Yeah, check it out.
So it's equal to the interior opposite angle.
Yes. That's a hard I want to see. What is it there? Right? So angle. So before you do the question, step back and see if you could find all the theorems you could possibly use. So you'll prepare yourself for when you actually start. Angle between tangent and Carissa, are you seeing what I'm talking about with the angle between the tangent and the triangle? Some of you seen.
As you pointed out here.
Nice. So that's not the only place it have it, right? You also have it over here. See that?
Yeah.
Right? Wait there. If you draw over here, yeah. All right. And there's one more. There's one more. This one kind of hard to see, but there's one more. There's one more. I'll give all a hint, right? Where's this angle? The angle is at the what? Where's the angle? C,
The center.
right? And this angle is at
Yeah.
the what?
The circumference.
Okay. Are they both standing on the same arc? I mean chord.
Yeah.
All right. So if you have an angle at the center, then the angle at the center will be how much times the angle at the circumference?
Twice.
Yeah. And that's all I see. Probably more, but that's the ones I see. Angle at the center is 2x. So let me ask a question. How much of these did you all see? So there were 1, 2, 3, 4, 5, 6, 7. Out of the 7, how much theorems did you see just by looking at the question? Tell me, guys. Sky. Oh, Sky stepped away. Jada.
How about
Oh, you're back. All right. How much theorems do you think you'd have been able to see out of the 7?
so automatically I saw the semicircle, the cyclic, and I think it was just three. The radius and tangent, so 90 degrees.
Okay. All right. So now that we know now that we expecting, they can't tie we up, right? We see through all the deceit. They can't trick us. So the first question, find the angle EHF. So first of all, where is that angle? So the angle is always the one in the middle. So we're looking at H. So EHF. So EHF. So they want us to figure out for this angle. Now that angle would be a what angle? Starts with B. B. BA. Remember, it's an isosceles triangle. So this would be a what angle? I hear it from anybody. That'd be a base angle. Right? And this would also be a base angle. So let me just take this diagram and draw like a smaller version of it. And if I'm losing anybody, you'll able to tell me, right? So essentially, this is H, this is F, and this is E. And they are telling us that E is 44 degrees. What theorem am I using here, guys? What theorem speaks about this? To set up the problem, what theorem am I using? Could somebody tell me? What theorem am I using? Ria, so you're on mute.
The tangent from a common point.
Are always equal in length. So that would form the
Oh,
isosceles triangle. Nice. And they want
so
us to find.
to
Yeah, you
H
continue.
and F to E.
So that again?
So from E to H equals to E to F.
Yes. Yes. That's correct. So if that's the case, wouldn't this angle here be equal to this angle? Tell me if that confusing, yeah? I feel like it might confuse you because in the diagrams, your custom scene is like this. It's always be like this. But this time around, it kind of rotated. So Ria, on a scale of 1 to 10, how confused are you?
1.
1? Okay, so you understand that this side and this side will be equal, right?
Mm-hmm.
And so those two angles will be equal.
Yeah.
Nice. And they wanted us to find for EHF. EHF, right? So EHF, that would be over here. That's what they want us to find. All right, so they want us to find for that. How would I find that answer, Ria?
So you're taking 180 and minus 44 degrees from it,
Mm-hmm.
which you'll get 136, and then you
So
divide 136 by 2, and you'll get 68.
if you wanted, you could have do the work in one time. So you could have said that angle EHF would be equal, right? And that would give you what? So 180 minus 44, that is 136. 136 over 2. That's
68.
68. Okay. Right, so this is going to be 68 degrees. So let's put that down. 68 degrees. I'm going to put the work in here. As you can see, there's really not much space for the working. So you can't really do any big set of working, right? And now you need to give a reason for your answer. Right? So let me just put on the theorem we use. Right? Tangents from a common point are equal in length. So we would say that you would say that EH is equal to EF. So EH is equal to EF, right? Right, so we use that, and you also need to talk about the fact that base angles in an isosceles triangles are base angles in an isosceles triangle are equal, right? So is there anybody that did not understand how I did the first question? Tell me.
I have a question, right? You have to put the word in, or you can just do the.
And you have to put it in. I would advise doing that. I mean, it's 2 marks, so I would advise you put your answer, you put it work in, and state the theorems you use.
Okay.
The theorems you use them. Right. Okay, so FGH. FGH. Now, before we continue, I want to let's get into the habits of, if you find an angle, put it into the diagram one time. So this would be 68, and that would make this what? What would this be? Somebody tell me, what would that be?
68.
Right?
Yes, sir.
Nice. And now they want us to find FGH. FGH. They want us to find for this angle, right? I think all I could see the answer one time, right? I think all I could see it like straight right away, right? What the answer will be? What would the answer be?
90 degrees.
No, you get caught. This would be 90 degrees. This wouldn't be 90 degrees.
Oh, so I get tired, but the triangle inside the semicircle.
If you want to use that, watch. This would be 90. See what I'm talking about, Sky?
Yes, sir. H.
All right, so let me show you what happened in here, right? So essentially, you have a tangent, and you have the triangle FGH. This angle here is in between the tangent and the triangle, so it'll be equal to the interior opposite angle. Some of you are okay with that.
Yes, sir.
Uh, Ria, Perseus, Carissa, Desron, Adetola, Mira,
Yeah.
bunch of people. Are they confused?
No.
Oh,
Oh, okay. So this would be 68 degrees. Right? So what I just use the fact that angle between tangents, so the angle between tangent and side of triangle would be equal to right? So you could say, therefore, angle EFH, angle EFH will be equal to angle FGH. Right, and that'll be 68 degrees. Nice. All right, so let me just draw like a separate diagram for that real quick. You have to say yes.
I remember I did a different working for this one.
Okay, you go tell me just now, right? Let me just draw a separate diagram. Like, truth be told, there's so much different ways you could work that question out. I'll go over some other methods, right? But there's so much ways you could work that out. That's what's very cool about maths. You have endless possibilities. All right. All right. This is H. This is G. This is F. This angle here, 68 degrees. So this angle here would have to be 68 degrees. Right. So Perseus, how did you do it? Like, I was very curious as to know as to like how you did it. Like, it's confusing me a bit.
So what I did, like when I put the reason as the quadrilateral, right? How like I was thinking about it, it's like all angles like add up to 360, and also I was thinking about the circle. And how I got the 90 degrees and add 90 plus 90 is because I put HOF and FOH because how the radii is touching the tangent. That's how like I was thinking of like the 90 degrees there. And actually, I was thinking like twice the circle, like twice the circumference. Also, that's why I like divide it to get the answer.
Okay, you're saying a lot of things, right? Now,
Yeah,
as seen as I could individually, I could see everything you're talking about, but together, I can't see it. So you're saying that 360 degrees, right? Now,
yeah.
now check this, right? Check this. Opposite angles in a cyclic quadrilateral would have to add up to 180. So, but you see, the thing is, in this diagram, look at what's going on. This would be 90, and this would be 90. Why is this 90? It's 90 because angle in a semicircle is 90. So this entire thing is 90. This entire thing is 90. This entire thing is 90. And this entire thing is 90.
That's
Right?
how I was next to like that.
But how do you use that to get an answer? That's my question.
Use like the 90.
Yeah, how did 90 come into play?
Well, practically for I is like adding up like 90 plus 90 equals like how each side like this is 190, this is 90, that 90, T's 90, F 90. And I just add up like get 180 for both, and that's how like I get the 360.
I feel like that could nah, I do like if you form
It's confusing. I,
I,
I
I
mean,
I do think you'll get full marks for that because
yeah,
it's like let me show you some other feasible ways to do it. I'll show you some other like 100% correct ways to do it, but
because also why I did 290 degrees, like for when I bracket it off, like 90 plus 90 plus the 44, those two I got it from FOH and HOF. That is where I got the both 90 degrees from. And
all right. Now as like, let me show you, right? Like, you're saying a bunch of theorems, but I can't see all of those theorems working together at the same time to give you the answer. Like, let me show you an example, right? Let me just say we want to use the angle at the center is 2 times the angle at the circumference, right? Let me just say we're using that. Wait. Um, can't really use that one there. Let me show you another way you could work it out, right? So, Perseus, I will look back at your answer in more detail, but it's still tough to chew, right?
It's quite understandable, so
Right. So I'll go through some other methods, right? So Sky, let me know if you're there.
Yes, sir.
All right. So you see how we figure this out using the angle between a tangent and a triangle is equal to the interior opposite angle. There's other ways to work it out. So let's look at the alternative ways to work it out. So I'm just gonna find for a bunch of angles and you see how it will play out. So Sky, tell me something, right? If you look at this triangle will be an example of a what kind of triangle? Do you think you know what kind of triangle this is?
So far, say isosceles.
Isosceles, correct. O to G is a what? What is O to G? So it's from the
My
center to
internet.
the circumference, center to circumference, what do you call a line? Center to the circumference. If a line is going from the center to the circumference as a radius, so this is a radius, this is a radius, so that's why it's a isosceles triangle, yeah?
Yes, sir.
All right. So we know that this is an isosceles triangle. Cool. It's an isosceles triangle. So therefore, this angle and this angle would have to be equal. Nice. So if we find for this angle here, you'd be able to find for these two angles. So let me show you how we're going to do that. So Sky, now this is a kind of convoluted process, right? But Sky, isn't this a radius and this a tangent?
Yes, sir.
Okay, so would it be possible for me to figure out this answer, this angle over here?
Yes, sir.
How would I find for the angle?
So it isn't the tangent with the angle between the tangent and the radius 90 degrees.
All right, so if the entire thing is 90 there, this would be 90 minus 68. What is 90 minus 68?
22.
22. Mm-hmm. So this will be 22 degrees. And I'm gonna ask you again, what kind of triangle this is? One of them is isosceles. Then you can see that this is isosceles because O to
Yes,
F is
sir.
a radius and O to right. So this would also be 22 degrees. Yeah.
Yes, sir.
Is it possible for me to figure out for this angle over here? If I know that this is 22 and this is 22, would it be possible for me to figure out for this angle?
Yes, sir.
Yeah. That'll be 180 minus 44. Where's 180 minus 44?
So 136. I'm not sure.
136. Mm-hmm. Right. And this is our straight line. So angle along a straight line is 180. So if I wanted to find for this angle, that'll be 180 minus 136. And that'll be 44 as well, and 180 minus 136. That should be 44, and
Yes, sir. I think it's
yeah,
44.
right, 44. And to figure out for these, I could say 180 minus 44 all over 2, right? 180 minus 44 is 136. 136 over 2 is 38. What's in 38? 68. It's quite a long process. There was another way you could work it out. So in this method, we found for this angle here, and once you know what this angle is, you could minus it from 180 and divide by 2 to find the two base angles for the isosceles triangle. Now, Sky, would you go through all of that pressure?
No.
No, right? No. Let me show you an easier way to work it out. Now, in this question, and you're seeing that you have two angles standing on the same arc or chord, and you're seeing that. Tell me if you're seeing that.
Yes, sir.
Okay. So if I was able to find for this angle, wouldn't that angle be same as this angle over here? Yeah or no? So let me run that back one more time. Anytime you have two angles standing on the same arc or chord, then the angle at the circumference will be the same. So if I'm able to figure out for this angle, I'd also be able to figure out for this angle. So Sky, do you know how I would find for this angle?
I kind of forget.
All right. O to H is an example of a what? What's O to H?
Radius,
Right? What's this?
a tangent,
What's the angle between a tangent and a radius?
90 degrees.
Right? So if this entire thing is 90 degrees, what would this missing portion be? So the entire thing is 90. Right? So this entire angle is 90. Right?
Would
This
it be 90 minus 68?
correct. The 90 minus 68. And you
That'd
get
be
20,
20.
22.
right? 22. And like I just said, if you
The
have
opposite side is 22.
not the opposite side, the other angle at the circumference will be 22 because they're standing on the same chord. Right? So this will be 22. And check this. We have an angle in a semicircle, right? So this would be 90. And if this is 90 and this is 22, how will I find for the missing angle here? Somebody tell me. So Sky,
90 subtracted by 22.
yes. And what is 90 minus 22?
68.
Yeah. I have a bunch of ways you could have figured out the question, right? But what I showed you guys was just the easiest, most straightforward answer. Yeah. Right. Right, so let's move on to the next question. All right. So the next question is asking us to find for JHE. JHE. So JHE. All right. This is an easy one. What would the answer be? So JHE. Right? So JHE, they're talking about this angle over here. What would the angle be, guys? And what's the reason for it? Somebody tell me. Ria, do you know what this angle will be? Yeah? No? Maybe?
No.
All right. Ria, let's look at what we have on the triangle, right? We have a what? What's this? What's that?
Tangent.
All right. What is this?
A radius.
So put it together. What would this angle be?
90.
Bam. See?
Oh.
Yeah.
I think it's the way it draw that trick,
Yeah.
man.
Yeah. It didn't look like 90. I didn't draw it. I didn't draw it like this because I couldn't have assumed that it was 90. We needed to actually prove that it was 90 first. Right? So I just draw this angle. But do you understand that the angle between the radius and the tangent is 90? Yeah?
Yeah.
Okay, cool. So this answer over here be 90. Cool. 90. Right, so JHE is 90 degrees. And the answer is because angle between tangent and radius is 90 degrees. Cool. JGH now. JGH. Sound like easy one, guys. What's the answer? JGH. We're talking about this angle over here. What would angle be, guys?
90.
90. What's the reason for that? Why is it 90?
Because it's in the semicircle.
The angle in our semicircle is always 90 degrees. Right? Right, so right. All right. So Carissa, do you understand why I'm saying I have to write the reason now? Because look for instance, this question, right? This is a 2 mark question. Did you do any calculations?
No.
Nah, you're not. You need to put your reason. You need to put your verbal reason. They didn't give any lines or anything though, but which is kind of stupid on CXC part, but you gotta make do what you get. All right. So guys, did I confuse you all? Is there any part you'd like me to run through? Thelma, Perseus, is there anything you'd like me to run through?
Yeah, sir. Good.
Okay. I'm not hearing from Desron, Mira, Adetola, Jada, Joshua, and Devon. Devon, you good?
Show me that.
You good?
Yeah, right.
Nice. Desron, I see you following along. All right. I will send these detailed solutions on the chat. Like as soon as class finish, I'll send these notes on the chat. All right, so time for the next question. The next question was from January 2016. Okay. If I could find it. Okay, here it is. Nice. Okay, so I need a volunteer. Mira or Adetola. I didn't hear from you guys in ages. So either one of you. Adetola, let me know if you're hearing me. If you're feeling shy,
Yeah.
like,
Most of today was real tiring.
oh shucks. So yeah, you're feeling drained.
Yeah.
I understand. Well, I promise it's not that hard, right? I promise it's not gonna be that hard. So get the question I read.
The diagram below, not drawn to scale, it shows a circle with the center O. TAE is a tangent to the circle at point A, and angle AOD is equal to 72 degrees.
Okay. And they want us to calculate ADC. So what would ADC be? Right? So ADC. They're talking about this angle over here. Were you able to see that?
Yeah,
Right, so that's what ADC means. And what's the answer? So ADC. So what do you think the answer is?
90 degrees,
And what's the reason for that?
because it's a right angle triangle.
You had to say more on that. The angle in
Yeah,
a semicircle, you had to mention the semicircle. You had to mention that.
oh,
So, so it's 90 degrees because,
The angle in the semicircle is always 90 degrees.
right, the angle All right, ACD. Right, so Mira, help me with this one. ACD. We first need to figure out where ACD is. Right? Before I move on, let me just put this is ADC. All right, so Mira, we want to figure out where ACD is. So ACD, that would be over here. Right? So we need to figure out this angle. Tell me if you have any ideas.
Is it the angle in the interior opposite angle? That's what we're looking at.
Now, I would say yes, right? I would say yes, because I mean, if you had, but first of all, right, Mira, do we have an angle over here?
No.
Nah. And even if we did have an angle over here, it would be for that. It wouldn't be for this. Yeah. So nah. Wouldn't be able to use that. So Mira, let's look at what we have in the diagram, right? Let's look at what we have in the diagram. In the diagram, we have an angle at the
At the center.
right, and this angle is at the think about it, Mira.
Is at the diameter, well, the radius.
The circumference.
Circumference. Okay.
Mhm. Is
Yeah.
there any theorems talking about center and circumference? Tell me. Are there any theorems talking about the angle at the center and the angle at the circumference?
Yeah.
All right. But do you think it's wise to use that one over there? Let's look at the original theorem. Now, if you want to use this theorem, right, let's pay close attention to something. So, Mira, when we looked at this like this is a previous example, right? Does this look like this? Yeah or no? It's not a trick question. Let me actually bring it side by side.
Um, yeah, it look kind of similar.
All right. So, can you see that for this to work, right? The angles must be standing on the same arc or chord. One has to go to the center and one has to go to the circumference. Let's see if we have that in the diagram, right? So Mira, in the diagram, right? This angle, where's it standing upon?
A and D.
All right. And it goes to the center. And in this diagram, what is that angle standing upon?
D and C.
Now check it out again. So imagine these two things are legs. So these
A and D.
A and D, right? Are both of them
Yeah.
standing up on the same chord?
No.
You sure about that? Let me look. Where's this one standing up on?
Yes, it's standing up on the same chord.
Right? The same way this one is like look at it. In this diagram, that angle 86 is standing up on AB and angle C is standing up on AB, right?
Yeah.
It's the same thing for this one. So in other words, if this is 72, what do you think the angle at the circumference would be?
72.
Not quite. Check how the theorems work, right? The angle at the center is 2 times the angle at the circumference. So if this is 86, this will be 43. And if this is 43, this will be 86. Have any, you think you understand that? Or nah? Still giving you some trouble.
Um, it will be 36.
Yeah, AB 36. Let me know if you guys understand that. Do you all understand that? Is there anybody that does not understand that? Adetola, Jada, Desron, Joshua, Ria, Carissa, Sky. You understand that, Perseus?
Yes.
All right. Carissa, you understand that if this is 72, this will be 36?
Yeah.
Okay, nice. Right? I'm gonna trust that we okay with that. Okay. All right. So Mira, I think you gotta work on. Yeah, I feel like after class you might have to go and check back the theorems. I don't remember, right? So
Yeah, I need to do that because I can flustered just by seeing these shapes.
because it's a lot, right? I mean, it's a lot. It's a bunch of shapes. I don't blame you. So you have to remember the fundamental theorem. If we look at that theorem, what does it say? Read that for me.
The angle at the center is 2 times the angle at the circumference standing on the same arc or chord.
So let's see if what we have meets that criteria. So first of all, where is this angle? This angle is at the what? Where's the angle, Mira?
72 degrees.
But it's at what point? It's at the circumference, the center. Where is it?
It's at the center.
Right? And it's standing upon. If these are legs,
A and D.
right? AD, chord, AD, that's a chord, right? And angle C now goes to the circumference and also stands up on AD. So does it meet the criteria for me to use the theorem?
Yes, it does.
It does. Now you have to understand they would change up the diagrams. The same diagram would never come back. So you need to know what you're looking for, right? Yeah. Right, so the answer for that was 36. And do you remember the theorem? Tell me the angle at the angle at the try to remember it. So the angle at the center is what?
Could you say it's equal to the angle at the circumference?
No. In these examples, were they the same?
Because it's
No.
2 times this.
No, it wasn't the same, right, Mira? Watch. What is the relationship between 43 and 86? What would I have to do with 43 to get 80?
86 is twice the amount of 43.
Exactly. So you need to say that the angle at the center is what?
Is twice the size of the angle at the circumference.
Right. It's twice the angle. And you need to mention standing on the same arc or chord. You need to. Right? So the angle at the center is twice the angle at the circumference. Standing. Right. And in this question, both angle and both angle AOD and angle ACD are standing on chord AD. Right? So Carissa, if you want to be fancy, you could specify those details, but it wouldn't give you extra marks, but it would look better. Like what I have here would give you full marks. But if you want to be very precise, you could put that. You could say angle ACD as well as angle AOD, both stand on chord AD. So angle at the center will be 2 times the angle at the circumference. You could say that, right? CAD now. So Adetola, back to you. CAD. 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 Tell me, Adetola, how you going to find for that? Hmm. CAD. Adetola, tell me what's going on. Hmm.
So since the angle of a triangle or out of 180 degrees, you can add the 90 and 36 and minus it from 180.
Perfect. So CAD equal to 180 degrees minus open bracket. What?
90 degrees plus 36 degrees.
Yep. 90 plus 36 is 126. So the answer should be 44. No, 54. Is it 54? Can I bring that
I'm
right?
checking it.
So that might be wrong.
Yes, 54.
Yeah, correct.
Okay. Right? The thing is, I don't understand how I could do a 24-hour marathon and not be tired, but like I'm feeling tired now. I don't understand how that work out, how that makes sense. Like right now, feeling real tired. Not gonna lie.
You don't want no sugar. You're weak.
You know, I feel like it, because I only eat this morning.
Same thing.
We boy tip on. I had KFC and you eat.
But KFC, look, in my honest and humblest opinion, KFC dry that. KFC can satisfy your hunger.
Hear
If
what?
you hungry by KFC, but in like 2 or 3 hours pass, you're hungry again. KFC, if you're only buying KFC, you're only buying nothing taste.
Now if you buy like a bucket of chicken, I would say I would fill you up. I mean, yeah,
Yeah, but that chicken, normally nobody don't go and buy a whole bucket of chicken. The man go and buy a box. Chips, chicken, probably like 2 piece, 3 piece, I don't know. Whatever the average university person could afford.
not true. You know
Come
what,
out a
Yvonne?
KFC
Hear what? Hear
chicken.
what? Hear what? That's Yvonne. When Monday, what we should do is we should buy a whole big bucket of KFC chicken and just share it to people in class. That'd be funny. We're real funny. Yeah.
The man guy watch it like, with this family.
Oh, all right. So the answer for CAD is just simply this, right? So Adetola, good job with part 3, right? And if you want, it's optional. This will give you full marks. You could also say sum of angles in a triangle is 180. But Adetola, you understand the working kind of implies that, so you don't really need to say that.
Yeah.
Yeah, right. OEA. Back to you, Mira. Let me see if I'm gonna catch you lacking. By the way, I not realize like these are the colors for like the Powerpuff Girls. I not realize that. If any of you know about the Powerpuff Girls, these are the colors. Like blue, green, and pink.
Totally, it's not red, it's pink, eh?
Pink,
So,
yeah, it's pink.
You remember the name?
No, I don't. I don't watch Powerpuff Girls. It's just like okay now.
Bubbles, Blossom, and Buttercup.
I'll put that in. Which one is which is the blue one?
The blue one
Bubbles.
is he hot head one named Buttercup.
Yeah, it's the one. The one
Hey,
talking about Bob, you so good boy. Hey, yeah.
that was my childhood dog. And the monkey man, Mojo, Jojo, some retarded name like that.
So the blue, what's in my blue one?
Blue one is bubbles.
Bubbles.
Yeah.
What's in my the green one?
Buttercup.
Buttercup.
The hot head one. That one that will fight.
And where's the pink one?
Blossom.
Blossom.
Awesome.
Right.
Do you know body pop of girls but never watch it, boy?
Yeah, yeah, no, no. I'll watch it.
You know the ingredients to make them?
No, I don't. Sugar and spice and everything nice or something.
Sugar, spice, everything nice, and I drop a chemical X.
You really know this thing, boy. Hey.
That's my childhood dog.
All right. Last one. So Mira. OEA. All right. So where would that be? OEA. I'll be right here. All right. What color I should use for that? Give me a color, Mira.
Um, what color do you have?
I have an infinite amount of colors.
Okay, purple. We go purple.
All right. I feel like if I had a Ford Powerpuff Girl, that'd be purple. Like I feel so.
No, the monkey already
They
purple.
had a fourth Powerpuff Girl. I just remember her name.
What
It
monkey?
was?
I
Wow.
never watched
Yeah,
Powerpuff Girls, so I don't know.
she came in like real late though.
I'm gonna look it up. Fourth Powerpuff Girl.
She was like blue. Like she had purple eyes and blue hair.
Okay. She look
I don't
she,
remember her name.
she looked like she gone pelt down somebody. She look real vexed. Watch. That's crazy. That's me when I give all the homework. Do all the homework. And then I see a bunny. Who's this about? Bunny, the Powerpuff Girls.
I don't know about no bunny in purple kills. That's the first time I hear about that.
I must send it.
I know, I know a good bit of characters from them, but I don't remember everybody. Bunny.
Yeah, I
That's
sent
what
bunny. He's like
Oh,
the big
I
purple
know
one.
what you're talking about.
All right. So let me figure out this one, right? So Mira, how would I figure out this angle? I given you 2 minutes to figure it out. Like talk me through it. Like how would you find the angle?
Well, you see, you have to go back in your rules, right? And
Mhm.
then you have to, well, basically figure out what you're gonna use to find the answer.
Okay. That was the most that's like asking somebody why is your name Rajiv? And I say my name is Rajiv. That was like
that's
a
the hard
that was like
answer I have in the but that one of the best answers me ever heard.
that's like a 360 Mira, I carry my loop there.
I'm
And
sorry, my brain lagging. I try and I really try.
I
That's the best effort. That's an effort.
all right, Mira, let me try to wrap your brain around this thing, right? So, Mira, if there are two
Yes,
if there are two angles in a triangle and you can figure out the remaining one,
yeah,
okay. So do you think it's possible for us to figure out this angle and this angle?
yeah.
It have a way, right? We need to find
Mm.
a way. So how could I
Wait,
figure out this angle and how could I figure out this angle? Mira, I'm
nah.
gonna it's a one, all right?
Oh shucks, I am mute. But
Mute your mic if you're gonna make noise.
yeah, I'm doing the circuit question and I see this man repeat the same question 3 times.
Manuja again, yes, but mute yourself. Right? We important. And so Mira, um,
Yes,
what kind of triangle is this?
an isosceles triangle.
And how do you know that?
because the base of the triangle is these same angles.
You don't know that? I don't
Two
know.
angles at least.
Typically, you would know something is isosceles if two sides equal. So if we could prove that two sides are equal, then you would be able to figure out for this and figure out for this.
Okay.
But here's the thing, right? In the previous question, we had figured out from we had figured out for CAD, right? So we know that this is 54,
Mm-hmm.
right? And if we prove it's an isosceles, then we'd be able to figure out that this is 54 as well.
Yeah.
You can see how easy it is, right? But I still didn't get a proper response from you. Why is this an isosceles triangle? What
You
is
know,
it?
if I say it look like isosceles triangle, I might get kicked out this
Say it.
class.
Who said that? Wait, I have a nice sticker for that. Wait,
Oh my God. You cannot be serious.
all right. Yeah.
Uh-huh.
Come now. Think about it, right? We know that a triangle is isosceles if two sides are equal.
Yeah.
What would I call O to D? What's the name for that? That's our
OD is a radius.
okay. Hold that thought, is a radius. And what
Mm-hmm.
is O to A? Center to circumference is a
Center to the circumference.
mm-hmm.
Um,
Starts with R.
Radius.
Yeah.
So you
Miriam.
have to be eyes.
Yeah, some work to do, you know. I'll send you back
I
all the
know.
details. I'll send you back the recordings. And if any of you need help, or you could message me at any time. If I once I'm free, I'll go like help all you. Ask Precious. You know, like Mira, if you need help, just send me a message. I'll get back to you. I care about all you,
All right.
right? But
Mm-hmm.
all you have to care about all yourself too, right? So Mira, look back at the recordings. And if I zoom out, you should be able to see it better, right? And you know a radius is just half of a diameter.
Yes.
Check it out now. You can see that as a radius
Yeah.
because if this is the diameter, it's half of it. And another reason why it starts from the center and it goes to the circumference. So if this is a radius and this is a radius, and in a circle, all radii are equal,
Yes.
right? So it's an isosceles triangle, we figure that out. So this and this equal, and as such, this would be what angle? What angle be on the inside?
54.
Yeah, 54. Mm-hmm. Remember what I told you. If I want to find for the purple angle, I need to figure out at least two other angles inside.
Yeah.
Mira, what would I call this? It looks like a what? Don't tell me it's a tangent, eh? It's not tangent. Not tangent. It's a secant, but that's beside the point. What would I call that? Starts with L. That look like a what? L. L-I.
Li.
Mm-hmm. L-I-N. If I get the last letter, I'll finish the word L-I-N.
I have no idea.
Align. Yeah.
What you wicked?
The one
Oh
line, right?
Boy,
What is the
my
what,
God.
what is the sum of
Okay.
what is the sum of angles about a line? Oh, you know that. So what is the angle along a line?
Uh-huh. 180.
180. That's correct. So wouldn't because this is a straight line and the
Yeah.
entire thing will be 180,
Mm-hmm.
and you know that this is 54, would you be able to figure out for this angle on the inside?
Yeah.
How?
Is it 180 take away the 54?
Yep, that's it. Don't worry, guys. My brain hurting me too. I real tired. So if I just say things that that don't make sense, I'll give all a pass. Because I feel like all are we going through it? And it's that.
First of all, I couldn't even tell what was a line. So I don't know.
No,
I'll
no,
give
no, no, no. That's your fault. He do that as a way for trick you. He do that like some trick
what?
question.
Come
And
on, no
actually,
boy. No white boy.
yeah, you
So I'm
might
trying
just
to
see,
incriminate me here.
but you just do that for Chewy
No
after.
boy.
That hell, really hell. What are you talking about?
All right.
That is on 4 letter.
So we have a line. I don't like this color. Give me a color, guys. Give me a color.
Blue. A
Teal.
dark one.
Teal. I think this is teal. I'm not sure. All right. So this is a line. That's a line. We know that. This
Yeah.
will be 180 degrees. Don't like what I'm looking. I feel like everybody more tired than usual today. I don't know where it is though. Something in the air maybe. All right. So
For
180
me,
degrees.
reason why I fed up now is because I see this man set up this assignment and shit. Like,
Hey, come on, language. Don't say them kind of words in the meeting.
yeah, my bad.
Yeah.
But the way
Mute your
he
mic.
putting up
Come on, we could talk after. Mute your mic. We lucky and we doing work. Right? Yeah. Right? So Mira, you understand
Yeah.
the angle would just be 180 minus 54, right?
Which is 126.
Right. Big up you. Right? 126.
Yeah.
Cool. So we find for one thing. Is it possible for me to figure out what this is? How would I find for this angle now?
Um, I was gonna say you find for the whole angle and then you take away 54 again.
I'm gonna help you out, right? What is that? Again,
A
I'm not trying to indirectly trick you up there. Um, this is center. This is a line from the center to the circumference. What do you call that?
a radius.
Right? And this is a line that touching the circle at one point. What do you call that?
A tangent.
What's the angle between a radius and a tangent? What is it?
90 degrees.
90. Here I see it.
Yeah.
So that's one of the theorems you need to know as well. Right? So if this entire angle here is 90, right? I think it's 90. Then what would the red angle on the inside be? So this entire thing is 90. You know that this portion over here is 54. What would this be?
90 take away 54.
Yep.
It'll be 36.
That's correct. I'll show you all some easier ways to work this question when we finished. Actually, I'll just show it now. Carissa, do you notice that we have a tangent, we have a triangle?
No, I didn't notice before. I have too much going on the screen right now.
How yeah, I'm telling you, these circle theorem questions is like when you do any circle theorem questions, it is be so much, so much. But Carissa, you see now we have a tangent here, and we have a
Right.
triangle.
Yeah.
And to have a theorem that says the angle between the tangent and the side of the triangle is equal to the interior opposite angle.
Yeah.
So watch, I could use that but in reverse. But check this out, right? So this 36 degrees here would be the 36 degrees over here.
Right.
You understand that?
So the most parts.
Right, let me run it back one more time. Let me show you what I'm talking about. Remember this theorem?
Yeah.
So this theorem can work in reverse, right? So, Carissa, if I remove 68 degrees there, it could work in reverse, and this will be 68 degrees. That's what I'm saying.
Yeah.
If I remove 50 degrees from here, using the same theorem, this would also be 50. And using back the theorem, this would be what? What would this angle be?
68.
Right. So I'm saying that in this question, you could utilize our same concept. Watch. So we have an angle here, a
Right.
tangent. So watch. Bam. That'll be 36.
Right.
Yeah.
But that's what we're finding for. That's the last question.
So, Carissa, we actually finding for the purple angle. But you see, the thing is, right? For me to find
Right.
that purple angle, I would first need to know what this angle is.
Okay.
I would need to know what this angle is and this angle is. There's also another way you could work it out, right? So, Carissa, if you look at the broader picture, we are trying to find for the purple angle, right? Purple angle. If you look at this big triangle over here, you know that this is 72, and you know that this is 90. How could you find for the purple angle?
The 72 plus 90 and then minus it from 180.
Right. And you would get, how would you get? I think it's like 18.
18, yeah.
Yeah, I feel like that was the easiest approach. No, I didn't see that until now. But
That was the easiest approach because all of this on the screen is very confusing.
it is, but you get the same answer because 90 minus 54 is 36. 36 plus 126.
Because
That's
I
it.
wasn't even watching like the smaller parts and dissect the whole triangle. I was listening to you on that.
Yeah, that's a lot easier. I'll put both, right? So, Mira, if you look at the diagram and you look at this bigger
Uh-huh.
triangle over here, this
Mm-hmm.
angle here is 72 degrees. This angle here is 90 degrees. 72 plus 90, take away 180 would give you this angle. Understand?
Yeah.
Yeah. Honestly, it
Well,
don't
you see, if I
do
had do that before and not look at the small things on the inside, I might have sounded a little smarter, but
but the at the end, you know, the thing about circle theorems is it have so much ways to arrive at the same answer. So much ways. So much ways that
So listen, right? Within all of it, right? To find the what is the OEA, which
mhm.
circular theorem we're actually looking at.
The only circular theorem, circle theorem you would have to use there is that tangent and radius 90. That's the only one.
Oh, okay.
That's the
Okay.
only one we use.
Okay.
So 180 minus 90, 72, right? Cool. So that'll be 18 degrees, and we use the fact that angle between tangent.
It's my radius.
All right, Carissa, pick a year. We'll speed run a question. Pick a year.
Mm,
Pick a year.
21.
2021, all right. May or June.
January, or June?
Yeah, pick one.
January.
All right. Okay, I'm not seeing 2021 here. Um, Take another year just in case. Not seeing 2021 here. Pick another year. All years is how our circle theorem question is. We could check out January 2022. Okay, this question looks nice. So, Carissa, let me jump straight into it, right? Before we even start, which theorems you seeing? Okay, I'm hearing Carissa. I was somebody. Oh, I see it on mute now.
Um,
Before we even start, which
it
theorems are you seeing?
looking like the no, that one no. So I see in the one with I see with the common point, the tangent from a common point.
Nah. Mm-mm. We only have one tangent here. If you wanted to utilize that theorem, you
Interior.
would need another tangent. But you just have one tangent over here, so you can't use that one.
The tangent from the interior opposite angle.
Yeah, you could use that one. So let me give you an example of how you could use that.
And the triangle.
Check this out, right? So you see how 3x is in between that triangle and the tangent?
Yeah,
That 3x would be equal to the 54. And in doing so, you could find for x. Right? So you understand that?
yeah.
Nice. Which other theorems you seen?
Don't know that much.
I'll give you a hint. It
The
had to do,
radius, the tangent would be the 90 degree.
right? You could also use that to find for x because this whole thing, 3x plus 2x will be 90. Uh, I'm going to give you this hint. Angle R and angle Q. I see Perseus raise a hand. Perseus, come through now. Come on.
So I had to leave for a little bit.
Oh, you had to
I had
leave
to,
a little bit.
yeah, I had to go and do something real quickly.
Okay, no problem.
Excuse, thank you.
All right, so Carissa, my hint is that angle R. Oh, look, Sky raising a hand. Sky, you good?
Yes, I think that's fine too.
You think you see it?
Yes, that one and another.
So what would be the theorem to use there?
So, well, I'm not sure if that is the one you're talking about, but the triangle inside of semicircle.
Oh, no, we're talking about two different ones, but I see what you're talking about. You're talking about this.
Or or
Yeah.
RPSQ sign on the same chord segment. So
Yeah.
that one.
Mm-hmm. Yep. So you call both. So Carissa, just gonna point out a couple other theorems, right? Right. Yeah, just gonna point out a couple more theorems, right? So Carissa, can you see that we have this angle here? And can you see that we have this angle over here? Tell me if you can see that.
Not really, but
I really,
okay,
it kind of, I know it's kind of hard to see, right? But let's look at it one more time.
yeah, yeah, I can see it.
So, and that would be what angle? What are we calling that angle specifically? What's the name for the angle? It was given to us. Any question? That would be angle Z. Right, so the same Z degrees. And what about, right, so we have this angle here. I want you to imagine these two things as legs, right? So Carissa, if we're imagining those two things as legs, what chord is that standing upon? So a chord is just simply a line connecting 2 points of a circle, but it doesn't pass through the center. So you see this would be an example of a chord. This would be an example of a chord. All those examples of chords. So,
S and P.
right, so it's standing upon S and P.
Right.
If you look at this angle over here, does it also stand upon S and P?
No.
You sure about that watch?
You know, I said passing. It's not supposed to pass through the circle. It's an R and P. No?
No, it's on S
Okay,
and
yeah.
P.
It's on S&P. It's on S&P. Yeah.
Right? Because you're thinking about these two things as legs, right? So it's standing up on S and P.
Yeah. It's on
So
S&P.
in other words, both of these are standing up on the same chord
See?
ST. And if that is the case, then the angle at the circumference will be the same. So that's another theorem to use. And Sky suggested it. She said that you have a diameter here, and so it would form a semicircle. So the angle in a semicircle would be 90 degrees. So this would be 90 degrees. Tell me if you're seeing that one.
Yeah, see the 90 degree.
All right, so let me speed run this. So determine the value of each of the following angles, show detail working where possible, and give a reason for your answer. So we need to find for x. Okay, we need to find for x. How would you suggest finding for x, Carissa?
I don't know.
All right, so essentially, if you're trying to find for x, you need a piece of information that you know. So, Carissa, remember you told me angle between a tangent and radius was 90 degrees, and you told me that.
Yeah.
So we know that, and hence we know that
Right.
this would be 90 degrees,
Right.
all right? So we know that that has to be 90 degrees. We know that. That's a fact. So if we know
So
that
the
that
other
is,
side would be 90 degrees as well?
this would also be 90 degrees, correct?
Right.
But you'll see why I'm considering this side.
Okay.
Right now, what am I interested in finding for? I'm interested in finding for angle what?
X.
Angle x. So you'll see why I'm doing what I'm doing here. Right? So I just highlighting the tangent on the radius. Okay. We know that this is 90.
Right.
So let me ask you a question. And if you add up this angle and this angle, it's supposed to be equal to 90.
Yeah.
So I'm gonna form my equation. So if I add up 3x and I add up 2x, it's supposed to be equal to what?
90 degrees.
Right? If you have 3x's and you add on 2 more x's, how much x's you have?
Yes.
If you have 3x's and you add 2x's, so imagine you have 3x's, x plus x plus x, and
5x.
how much?
5x. Right.
Right? 5x's. All right. And so 5x would be equal to 90.
Right.
So how would I find for 1x now?
You divide the 90 by 5?
Correct. So I would divide both sides by 5 to find for 1x. Right? And 90, 5
That's
into
18.
90, that should be 18. Right? So let me know if you understood how I found for x.
Yeah. So
Nice.
then 18 by 3 will be 54.
Right? So this angle here, this one, this would be 54.
Right. And 18 by 2 is 36.
And if you add up 36 and 54, it gives you back the 90.
Right.
So that was one way you could do it. And the reason would be
What does it okay?
angle.
I don't
Yeah, I was saying something.
No, go ahead.
So let me know if anything confusing you at all.
No, that wasn't confusing.
They understand why I actually consider this side as opposed to this
Yeah,
side.
because it have more to work with.
And not just that.
And it's on the 90, you get it 90 degree.
Correct. If there's an unknown, the chances are I want to form an equation to solve for it. So I knew 90, and I knew that when I add up those, I would get 90. So I was able to form my equation. Right? So the reason was angle between tangent and radius is 90 degrees.
90.
And I'm working over there. So that's good. Right?
We get a copy of this by chance?
Yeah, I'll send this immediately after. Right? I send the notes and recordings immediately after fast. So everything is there. Everything is documented and all the resources could be accessed at any time. So angle Y now. Let me try to figure out for angle Y, right? How would we find for angle Y? Oh, by the way, before I move on, first I remember I told you that remember I was kind of pointing in this direction. I said if you have a tangent and you have a triangle, wouldn't the angle in between them be equal to the angle in the
And the opposite, yeah.
right? So in
So it
if I
ended
want
up
to,
being 54.
yes, I cannot say that 3x is equal to,
54.
and if I divide both sides by 3, and x would be equal to what?
You need to add that part more. That part will get me confused.
This is just an
Another way?
yeah, it's just another way, right?
I
Watch.
don't need that way.
I just tried to show Mr. Guns all the possible ways. Because somebody might like the previous method more, some people might like this more, right? But honestly, this is the easier approach. But if you saw this first, that's fine. Remember, guys, the angle between the tangent and the side of triangle is equal to the interior opposite angle. So you could have also said 3x is equal to 54 degrees. And Carissa, if I wanted to find for x now, what would I do? Yeah, sorry about that. If I wanted to find for x, what would I do?
That one I don't know.
So, so if I have 3x is equal to 54, how would I find for x?
54 divided by 3.
Yeah, and what is 54 divided by 3?
18.
Yeah, isn't that the same answer we got using the other method?
Yeah.
Yeah, so there's a bunch of different ways you could work the same question. That's the cool thing about maths. Right, so y. So let me figure out y now. So how do you suggest I find for y?
RS. I don't know.
So this one confusing you a little bit. All right, check this out. If I were to find for angle z, do you think I'd be able to find for y?
Yeah.
Yeah. And an even simpler way to
But
think about it.
so but PQ when the
So like I said, there are multiple ways you can think about it. The easiest approach would probably be to do what Sky said. Right? Sky was kind of suggesting it. So, Carissa, if you look at this triangle, right?
right.
Wouldn't this be 90 degrees?
Yeah.
What is x? Remind me, what was x? We found x earlier.
Then
Yeah. In the first part, they asked us to find for x.
18.
So, if you want, you could look at this triangle separately. This would be 90, and this would be 18. How would I find for angle y now?
The 90 plus the 18.
Right? 90 plus 18, take away from 1.
180.
Correct? I did get your answer one time. Right, so this would be 18 degrees. Mira, I hope you're following, eh? I'm looking at you. I can't see you, but I'm looking at you. I hope you're following.
Yes, I am.
So do you understand that, this is not a semicircle, so this will be 90?
Yes.
All right. And we found x to be 18. So the only thing we're missing inside this big triangle is y. So the find for y is just 180 minus 90 plus 80. That's it. Right. So, Carissa, how you feeling about y? That one was kind of simple.
Yeah, but for me, I watching the smaller circles and not really triangles are not really looking outside of that. So that's why kind of a little more difficult to
because
determine what.
there's so much to look at, and like it's like it kind of overwhelming with information.
Yeah, so like if when they say y, I would be more focused on the y instead of like same as half of a semicircle.
I know
So much
this
from the semicircle perspective.
this come with like years of practice on like me doing maths
Right.
and tutoring. It not easy, right? You just have to keep practicing circle theorems. Like you just have to keep practicing. But my advice is as soon as you start a question, go to the side and write down all the theorems you could possibly use. So when you work that out, you got 72 degrees.
Yeah.
Nice. Right. So the answer for y, just put on the working. Right. And for this question, we utilize the fact that angle in a semicircle is 90 degrees. Right? Time to figure out for z. Now this one is really, really simple. So, Carissa, if you know what y is, what do you think z is?
You see?
Say that again. I'm not hearing you properly. I hear a lot of noise. Like a lot of wood.
Same.
You said that they would be the same?
Mm-hmm.
That would be correct. And why? Why would they be the same?
To me, it looking like it on the same. What's called chord?
Mm-hmm.
To me, it looking like that.
Right? So you're correct. Angle Q and angle R are both standing on the same chord. So the angle at the circumference would be the same. And so angle Z is equal to 72 degrees. And Y, the angle at the circumference, the angle at the circumference standing,
On the same chord.
standing
On
on the
the
same,
chord.
right, same arc or chord. You're probably wondering why we just say arc. Actually, why we just say arc. So you can think of arc as just a piece of the whole circumference, right? So
The
you see,
circumference. The circumference is what exactly?
the circumference is this entire thing,
The
the,
entire circle.
the
Okay.
entire distance around the circle. So
Right.
when I say arc, a arc is just piece of the entire distance. So you see, like you see S to P here, that would be
Yeah. Like,
yeah, we're saying something.
no.
Oh, I could have swear here say something, right? So S to P is an arc
Mm-hmm.
because it's like it's piece of the whole circumference, which is the entire distance around the circle,
Okay.
right? Okay, so Sky, Perseus, Mira, Jada, Ria, Joshua, guys, let me know if you have anything on you want me to run through back. Adetola, anything on you want me to run through back in this question?
Awesome.
Nah,
No,
Adetola, you think you'll have figure out this one? Like, especially with the X's and all kind of thing?
not really. I think that was like my relative.
You think this one will give you some trouble?
Yeah.
So, what about the X confusing you exactly? Is it because it's a letter?
But I feel so. I feel like this.
So let me just run through
Like
that.
two more.
Let me run through that back one more time. Like I feel as though when you're doing the question, you mightn't maybe you would not see that you had to form an equation. I feel like you would not see that.
I don't think so. I don't think I would have that.
So let me run that back one more time. So in the first part, they wanted us to find for x, right? So Aditola, x is our unknown. If I want to find for unknown, chances are I want to make an equation. So Aditola, if you have a radius and you have a tangent, what's the angle between them two? What's the angle?
My right angle,
It's a right angle, right? And how much degrees is that?
90.
So check this, right? So do you understand that between a tangent and a radius is 90 degrees? That like you're 100% sure, right?
Yeah.
Okay. And if you notice, on the inside, we have parts of that entire thing. So over here I have 2x and over here I have 3x. So tell me, if I add up the 2x and the 3x, what is supposed to give me?
5x. I would have figured like one whole angle.
Right, and what is the whole angle equal to?
Only 90 degrees.
Right, check it out. The 2x is this small piece, and the 3x is this small piece. But what is the whole thing? What is the big angle there? What is the entire thing?
The 90 degrees.
Mm-hmm. So you understand if you add up 2x and you add 3x to it, that's supposed to be equal to the entire thing, which is 90 degrees. Tell me if you understand it now.
Yeah.
What is 2x plus 3x?
5x.
Mm-hmm. And to find for 1x, what would do?
We'll divide 5 on both sides.
Right? And so you get 18. Now, I feel like even though you understand it in class today, if you see this question for the first time, it might be tough. What do you
I
think?
think it must think. I'll have to think about it.
Yeah, because I understand why I would be confused. You see in 2x, you see in 3x, but normally they would give you an angle length.
Yeah.
Yeah. Anytime you see a question like this, try to come up with an equation to solve for the unknown. So you understand that the entire angle is 90. Well, then these two pieces had to give you back 90. So that's why I made it 2x plus 3x is equal to 90. And once you know what x is, you could go on you could you could actually put the values for here and here and here. So
Okay.
still confused?
No, I understand.
All right. So yeah, guys, that'll be it for class today, right? I'm going to send some homework. I'll send 2 questions. And as soon as you all are done with the questions, send it to me and I will correct it. So Mira, I hope you're gonna practice, eh?
Yeah, I will.
Uh,
I'm
and
sure by next class I'll be better.
that's good. That's the hope. That's the mission. So yeah, guys, thanks for coming to class today. Right? I hope all you have a blessed night and I hope all you sleep good. I hope nobody has any nightmares. Yeah, guys, later.
You too, sir.
I
Bye.
hope I hope all you don't dream about circle theorem. I feel like if all you dream about circle theorem, I'll go ball.
I mean, like, why would we dream about that?
Because we do so much today in class. Yeah.
I
But
would
later,
be more scared to dream about that.
yeah,
The only thing I'm looking up is functions. That's it.
functions on you scared of functions.
Yeah, and variance.
Okay.
Those two.
Right, Joshua.
Um,
Yeah, Priscilla, come on.
I'll just send you a message after class.
Okay,
Since class.
not a problem. Well, yeah,
Good
guys.
night. Bye.
Bye bye, everybody.
Bye.